Good morning, children. In today's class, we are proceeding to equation of lines. Given an equation of a line ax plus by plus c equal to 0. How am I to find slope of it? Slope of this equation is minus coefficient of x by coefficient of y. Here, coefficient of x is minus a by coefficient of y is b. Suppose I want a parallel line. Remember, parallel lines have same slope. That is, x and y, there is no change. Parallel lines differ by a constant. So, if I need a parallel line for this, it will be ax plus by plus k equal to 0. Parallel lines have same slope, telling us m1 equals m2. The next idea, perpendicular lines. When I want a perpendicular line for a given equation, put x coefficient to y coefficient to x. That is, b will come here, a will go here. How will I write it? bx minus ay plus k equal to 0, where k is a constant. Remember, whenever the lines are perpendicular, slope of the first line into slope of the second line gives us minus 1. So, how am I to write the equation? Interchange x and y coefficient. Also, change the symbol of either x or y. Change the constant also. When two lines intersect like this, how am I to get the point of intersection? We have to solve them. So, whenever two lines intersect like this, to find the point of intersection, let us try to solve the two lines. Now, there is a line and there is a point. The line is ax plus by plus c equal to 0 and the point is x1, y1. I am dropping a perpendicular. How to find the length of this perpendicular? We have the formula. See, the point can be above the line or below the line. So, put modulus ax1, that is the equation. Wherever xy comes, put x1, y1. ax1 plus by1 plus c by root of a square plus b square. Given the equation ax plus by plus c equal to 0, given the point x1, y1, perpendicular distance of the point from the line is modulus of ax1 plus by1 plus c by root of a square plus b square. Supposing two lines intersect and a third line is passing through that. How to get the third line? The third line is a combination of the first two. How will I write it? First line is a1x plus b1y plus c1. Second line is a2x plus b2y plus c2. Combination tells me one line plus lambda times another line equal to 0. I can put lambda k, any constant here. So, one line plus lambda times another line equals to 0. So, this is the new line that is passing through the intersection of 1 and 2. How to get the distance between parallel lines? So, this is a line, this is parallel to it. How to find the distance? Parallel lines differ by the constant. So, find the difference between the constant modulus divided by root of a square plus b square. So, whenever I want distance between two parallel lines, check x has same coefficient, y has same coefficient, only the constants change. So the formula is C1 minus C2 by root of a square plus b square. The next idea, in most of the problems, we will be asked x-intercept. So this is an equation. If I want x-intercept, put y equals to 0. If I want y-intercept, put x is equal to 0. If you want x-intercept, put y equal to 0. And if you want y-intercept, put x is equal to 0. And these are a very few formula that we will be often coming across in this exercise. Exercise 6.3, question number 1. Show that the lines are parallel. Let us remember the formula. Slope of ax plus by plus c equal to 0 is minus coefficient of x by coefficient of y, that is minus a by b. The first line 3x plus 2y plus 9 equal to 0. Slope m1 is minus 3 by 2. For the second line 12x plus 8y minus 15 equal to 0. The slope m2 is minus 12 by 8. Cancelling 4 table, it is minus 3 by 2. m1 and m2 are equal. Implies the lines are parallel. Question number 2. Find the equation of the straight line parallel to 5x minus 4y plus 3 equals to 0 and having x-intercept 3. Any line parallel to 5x minus 4y plus 3 equal to 0 will be no change in x and y. 5x minus 4y. Change only the constant. So instead of 3, let us put k equals 0. How to find k? There is another clue in the question. Having x-intercept 3. Given x-intercept equals to 3. Therefore, x-intercept tells me y is 0. So put y is 0 when x is equal to 3 in equation number 1. 5 into 3 minus 4 into 0 plus k 0. Simplifying which I get k equals minus 15. Do not stop the answer with k value. Put it back in first equation. So the required line will be 5x minus 4y minus 15 equal to 0. Question number 3. Find the distance between the line and a point. There are two subdivisions. Both are one and the same pattern. Given the line, compare it with ax plus by plus c equal to 0. A is 4, b is 3, c is 4. The point given let us consider as x1, y1. Remember the formula. So the distance, I can say perpendicular distance equals to modulus of ax1 4 into minus 2 plus by1 3 into 4 plus c by root of a square plus b square. Simplifying which minus 8 plus 12 plus 4 by root of 16 plus 9, or it is 8 by 16 plus 9, 25, square root is 5. So the perpendicular distance is 8 by 5. The same pattern let us apply here. The perpendicular distance here x1, y1 is 7 and minus 3. 4 into 7 plus 3 into minus 3 plus 4 by root of a square plus b square. 4 square plus 3 square. Simplifying this, 28 minus 9 plus 4 by root of 16 plus 9, that is 23 by 5, and hence the problem. Question number 4. Write the equation of the lines through the point and parallel to. Second subdivision, through the point and perpendicular to. Let us remember how to write a line parallel to x plus 3y minus 4 equal to 0. We do not change x or y. Change only the constant. Because there are two subdivisions, use K1 here. Given, it passes through 1, minus 1. What do you mean by passing through? It must satisfy the equation. Wherever x comes 1, wherever y comes minus 1, plus K1 equal to 0. 1 minus 3 plus K1 0, or K1 is minus 1 plus 3, that is 2. Put it back in this equation. So the required equation is x plus 3y plus 2 equals to 0. Similarly, the second subdivision tells perpendicular. How to write perpendicular line? Interchange x and y coefficients. 4 will come here, 3 will go here. So I will write 4x, 3y. Change the symbol. Plus comes, you write it as minus. Minus comes, you write it as plus. So 3x plus 4y given, I write it as 4x minus 3y plus K2 equal to 0. Again, it passes through 1, minus 1. Substitute. Wherever x comes 1, wherever y comes minus 1. As I simplify, 4 plus 3 plus K2 0, or 4 plus 3 7 goes to the right as minus 7. Put it back in the equation. So the required equation is 4x minus 3y minus 7 equals to 0. Question number 12. Find the distance between the parallel lines. 12x plus 5y equals 7. 12x plus 5y plus 7 equals to 0. We know the formula distance between parallel lines is C1 minus C2 by root of a square plus b square. Let us rewrite the equations having the constants in the left side itself. 12x plus 5y minus 7 equal to 0. Another equation, 12x plus 5y plus 7 equals to 0. Compare. A should be the same coefficient of x, that is 12. B, the same coefficient of y, that is 5. C1, first constant. C2, another constant. Substitute in the formula. The required distance equals to modulus of C1 minus C2 minus 7 by root of a square plus b square. That is minus 14 by root of 144 plus 25. This is 169 and the square root is 13. Since we have modulus, let us write plus 14 by 13 as the distance. The same pattern let us try here. But 3x, 6x are coming. So we need to make both the coefficients to be same. So first equation, let us multiply by 2. It is 6x minus 8y plus 10 equal to 0. Second equation, 6x minus 8y minus 15 equal to 0. Now let us compare. X coefficient the same, a is 6. Y coefficient the same, b is minus 8. Constant 1 is 10, constant 2 is minus 15. Let us substitute in the formula. Distance between the parallel lines equals to modulus of C1 minus C2, 10 minus of minus 15 by root of a square plus b square, 6 square plus minus 8 the whole square. 10 plus 15 by root of 36 plus 64. That is 25 divided by 64 plus 36 is 100 and the square root is 10. Cancelling which I get 5 by 2. So the required distance equals 5 by 2. Question number 13. Find the family of straight lines perpendicular to 3x plus 4y minus 12 equal to 0 and parallel to the same line given. Any line perpendicular to, let us remember the formula, interchange the coefficients. So 4 will go here, 3 will come here. Remember, change the symbol. Plus comes, you write minus. So there are 3 rules to remember. Interchange coefficients of x and y. Change the symbol of either x or y. Mostly we do y. Plus introduce a constant. Since I want family of straight lines, let me write K1 belongs to real numbers. As I change K1, I will get many lines. Now the question is parallel to. For parallel, I write x as it is, y as it is, change only the constant. Similarly, let us write K2 is a real number. As I keep on changing K2, I will get the system of parallel lines with a given line. Sixth question, find the equation of the line passing through the point of intersection of 4x minus y plus 3 equal to 0 and 5x plus 2y plus 7 equal to 0 and passing through minus 1, 2. Any line through the intersection of two different lines is a combination of the two. How do I write? First line, say 4x minus y plus 3 plus lambda times the second equation. So we say this as a linear combination of the two lines. Given it passes through minus 1, 2. What do you mean by passing through? Wherever x comes minus 1, wherever y comes 2. 4 into minus 1 minus 2 plus 3 plus lambda into 5 into minus 1 plus 2 into 2 plus 7 equals 0. Minus 4, 3 minus 2 is 1 plus lambda into minus 5 plus 4 plus 7 equal to 0. Or minus 3 plus 6 lambda equals 0. 6 lambda is 3 or lambda equals 3 by 6, that is 1 by 2. Substituting back in equation number 1, I get 4x minus y plus 3 plus lambda value 1 by 2 into 5x plus 2y plus 7 is 0. Taking LCM, 8x minus 2y plus 6 plus 5x plus 2y plus 7, 2 into 0, 0. 8x plus 5x, 13x. Minus 2y plus 2y cancels. 6 plus 7, 13 equal to 0. Or 13 I can divide. My answer is x plus 1 equal to 0. And this is the line that is passing through the intersection of the given two lines.